if I haven't even made a good faith attempt to cover them. I will ask your forgiveness, once again, for if I can't cover these in the level of depth that I would like to. And I would again point to my office hours later this week, to the course reviews, and the course review session, and to the opportunities to discuss these after class as ways that some questions could be resolved. The first thing I wanted to do, which is going to be very, very brief, is just sort of wrap up some discussion of debugging. I tried to articulate some of the basic flow of what's sometimes called the scientific debugging process last time. It's a process where one doesn't flail without just trying to get your program to work by tweaking things and see if this change works, that change works. It's a process of careful observation, reflection, and changing either the input that's causing the problems or the program to see if you can get the problem to eliminate at some point, which might give you a hint as to what pieces of the program are involved, what pieces are critical, and the problem being manifested is often an indication of what might be at fault. And there's a whole iterative process there. There's been descriptions of this process in a number of really good pieces of work. I showed you a book at one point by Zeller describing the systematic debugging process. And this is his description of the basic process. So you identify this problem, often in a team context from a database. You reproduce it, and you automate and simplify that test case to make it really easy to reproduce, so it's reliable. You can just make it happen every time. Then you try to identify possible origins for where things might have gone wrong, focusing on the most effective ones to sort of iterate through this process of trying to focus on a particular hypothesis based on some criteria, based on some past anomalies, bad smells in the code, the fact that certain code is kind of crufty or certain code is hard to understand. And you try to iterate until you can get to a situation where you've identified something being off. Once you've identified something being off at a certain place, you track down where the failure is, for example, where that's occurring. Or you've tracked down something that's off just before the failure. You work your way backwards. You work your way up the so-called infection chain to find out where it started. And often this involves simplifying code as a sort of temporary modification of the code, a copy of the code that you're working with just on a temporary basis to minimize how much is going on. And finally, you identify the source of the defect. So you work your way back. You work your way back from the failure once you've localized it to the source. Okay? And often, a key part of this is using tools. And one of the most critical tools we use is actually printf statements that print out at different states of the program what's going on. At the most basic level, when we try to localize the failure, when we try to figure out where that failure has occurred, we see the program crash. Where did it crash? We see it hang. At what point did it hang within the program? We can use a printf for doing that. We sprinkle printfs in, and we see how far it gets. We see, oh, it passed this one, it passed that one, it never got to this third one. That gives a hint as to where it might be dying. You sprinkle in some more printfs to sort of resolve the remaining ambiguities. And if you sprinkle them in a clever way, like doing a binary search type of approach, you can often quickly localize where is this stuff. Once you've done that, even with this simple mechanism of printf, you can start inserting printfs that instead print out the value of variables just before the failure. They print out sort of information on the current state of things, print out information maybe on what's allocated, etc. And you successfully work your way back. Work your way up until you find the source of what's off. Often by printing out variables, we're casting around and we find one of them that's off. We find a null pointer. Or we find that this dictionary has a null key in it. It has a key which shouldn't be able to be inserted into it. So we do printfs all back through the program, and until we can find the earliest place where that's inserted. So even with the very humble mechanism of a printf, or if you're in Java, could be system.out.println, we can work our way back on this sort of cause chain as to what's caused this failure, to find the underlying fault, right? The thing that led to this failure. This is a very, very simple option. It's not so flexible. It requires inserting printfs and maybe stripping them out later. Although if you've made a copy of the code, you might not have to do that. And often you're sorting through a lot of output. So there's additional mechanisms that can be used. One is to use logs. And for those who take my later class 371, you'll hear about a framework for Java called log4j. And this framework, for example, allows you to put through your code logging statements in the code that are always there. They're not there just because of a bug. They're there all the time. What's different is that dynamically, at runtime, without recompiling the program, you can enable or disable different levels of logging. So you can have it log only the most important things. You can have it log even the most detailed things. And you can change that for a simple configuration file. So here, all throughout our program, we've got these log messages. And associated with each log call to the logger, it says how important a matter this is. Whether it's sort of an issue of minutia, or whether it's something really, really important. Something really, really important might be connecting to the database, or trying to connect to this key server that we're going to work with. Something that's a minutiae might be something like updating the status bar at the bottom of the screen, or something like that. The good thing is, most of the time these aren't enabled, so they have essentially no cost. And we can enable them without recompiling them further. So we can flip a switch, turn them on, get lots of output that we can then browse at times when we need it for debugging. You're not doing that work inserting things every time separately for a different bug. Instead, it's kind of built in. Okay. So logging is a very effective technique, and it's one that can be kept to a minimum, and one that doesn't often involve recompiling the program. Another option that you folks are working with is use of a debugger. And a debugger can be a very, very effective tool when coupled with hypotheses as to what's going on. And it can be effective at exploring to generate hypotheses. So key point is you have to compile it with -G options, so it can pack all sorts of symbolic information in on what the variable names are and what particular line of machine language code that the computer can understand maps to a line of .C code, for example. So with this interactive debugger, as you've seen, you can watch variables, have it stop when they change, you can set breakpoints, you can have it print out the value of variables. You can, in fact, modify the value of variables or the values in memory, and you can have it step through the code. So there's two key commands for stepping through, next and step. So step executes until some other line is reached, and next evaluates the next line, including evaluation of a full function call that occurs on the next line. Okay, you've seen at least display within your labs. Display basically will show the value of some expression every time the program stops. And watch sets a watch point. It allows you to be alerted to have the program stop if an expression, for example, changes or requires some value. And we can set conditional breakpoints that conceptually sort of combine the features of those two. So these sort of interactive debuggers are very helpful for exploring what may be going on, but they don't solve the problem of debugging. They are a tool that has its place, but often they're most helpful to explore what's going on right around the point of failure and to follow hypotheses about different lines of infection that might be leading to that failure. Hypotheses where you can get it to stop earlier. So instead of putting in printf statements, you can do so with the debugger. Ladies and gentlemen, it's extremely important that you realize that your ability to debug things is not contingent upon having a debugger. I've debugged pieces of hardware that I've created using nothing more than a blink of a light. I've been able to track down a particular line where something is. And a debugger is a luxury. It's great to have. It can speed up the process. But remember, the humble printf statement is your friend. And if the debugger is throwing you off, if it's confusing you, if it's getting in the way, you can fall back to simple things like printfs or logs. You folks in the course of your careers will be encountering many debuggers. GDB is a particularly popular one. It may be the most popular one out there, but you'll find great debuggers built into tools like Eclipse, which you'll be using in the higher level courses, built into tools like Microsoft side, Visual C# or any number of tools there. The debuggers there are graphical. They allow you to manipulate quantities visually, to double click on the values of variables to change them, to click on a plus sign and explode the presentation, for example, of a pointer to a structure. But fundamentally, they deal with the same basic concepts that GDB does. You can set watch points. You can set breakpoints. You can have it go on a step-by-step basis on each successive line, or execute the whole next line. So they're nothing too different there. They're wrapped up, they're prettified, they're wrapped up in a nice user interface, they're prettified, they're made more visual, and that's often helpful, but they're not fundamentally different. So you should find yourself readily situated when it comes to those sort of graphical debuggers. So I've just concluded some comments